Hey guys, in this video we are going to do the second part of 2.4. So in 2.4 part A, we talked about dividing with polynomials and using long division, talked about the remainder theorem and factor theorem, but in this video we're going to kind of look at the opposite side of things. Instead of dividing with polynomials, we're going to talk about multiplying them, and specifically we're going to talk about raising binomials to a certain power, because if you're just multiplying polynomials, you just use FOIL, right? But raising binomials to a power is a little bit more complicated, unless you want to just really do the whole thing. And if you work the whole thing, yeah, that's fine, but it's a whole lot of work. So we can actually make a little bit of a shortcut, but we have to discover this pattern. And that's what we're going to go on a journey together to do really quick. So what you're seeing here is we're going to fill in these notes about raising binomials to a power. We're going to see if we can look at the pattern and maybe possibly make a prediction. Now, what I want you guys to do is have a piece of scratch paper handy so that we can do a little bit of algebra on the side and then come back and fill in our notes. Okay, so not only do I want you to have your notes and be filling these in, but I want you to have a little scratch paper on the side so that we can do a little bit of work, and I'm going to be doing that as well. Okay, so when we raise binomials to a power, we're going to actually kind of work through some of these. Okay, now some of it is pretty straightforward. I'm going to put one of these on here where I've got a little bit larger print, so a little larger notes there. But we're going to kind of just go through each of these one at a time, okay? And we're going to actually, it's going to look a little bit strange here at first just because of the way that I'm filling this out. But I want you guys to try to match the same kind of pattern that I'm going to be filling in, okay? So when we work through this, we're going to have everything raised to a power. Now, anytime you raise anything to the 0 power, always, no matter what it is, it could be 847 billion. Raised to the 0 power, your answer is 1, always. Okay, so I'm putting my 1 over here for a reason, so just bear with me. Put right over on this side, okay? Let's go down to the next one. If I look at a plus b to the first power, anytime you raise anything to the first power, you just get that same thing back, okay? So this is simply a plus b. Okay, now something I want to also add in here, okay, because you're going to start seeing some interesting powers or interesting situations. Okay, I'm leaving a little bit of space on this for a reason, because I'm going to come back and put a few things. All right, so just bear with me, because there's going to be a pattern that we can kind of follow. All right, here we have a plus b to the second power. So this is the first time I'm really going to need us to work it out separate. So this is where I'm going to go to my little scratch paper, the second separate piece of paper. Okay, I'm going to go to my scratch paper and I'm going to work it out. So if I do a plus b to the second power, it really is just a plus b times a plus b. And if we FOIL this, we end up with a squared, so a times a, right? Outside times outside, so that's ab. Inside times inside, so b times a is still just ab. And then b times b, last times last, makes b squared. Now you can combine some things, so this really would be a squared plus 2ab's plus b squared. Okay, this is what I'm going to put in the line on my actual notes. Okay, so this was scratch paper right here. This is scratch paper. Go to your actual notes, and we're going to put this as a line. Okay, so I'm going to put it down here. We're going to have a squared plus 2ab plus b squared. All right. Okay, go to the next one. The next one takes a plus b and cubes it. So I want you to think about what a plus b cubed is going to be, okay? I'm going to take this down here. We're going to take a plus b and cube it. Well, that is a plus b times a plus b times a plus b. Now, I want you to look at what we did a moment ago. A moment ago, we had a plus b times a plus b, and that was this right there. I'm going to replace this with that so I don't have to do quite as much work, okay? We could multiply it all out from the beginning, but who wants to? So I'm going to just replace that bit so I don't have to do all that math again. Oops. Okay. I didn't mean to close my parentheses yet. We're going to put a plus there. Okay. So to actually cube it, we're going to take that piece and we're going to then FOIL this through. Okay. So we're going to take a times that first term. You're just distributing a through the whole thing and then distribute b through the whole thing. So a times a squared, a cubed. A times 2ab plus 2a squared b. A times b squared, a b squared. Now I'm going to take b and multiply it through the whole thing. So this is b times a squared. That is a squared b. B times 2ab, 2a b squared. Then b times b squared, b cubed. I know I'm going through that kind of quick. You can always go back, slow down the video, watch it again. But that is me multiplying the a through those three, and then take the b and multiply through. Now we're going to combine our like terms. We have an a cubed. He's done. I'm going to cross them off as we go to make sure we combine everything. Everything that is a like term. Now I'm seeing here 2ab. There's another 2a squared b. We have another a squared b over here. So 2a squared b plus 1a squared b equals 3a squared b. That combined this guy and this guy. All right, now I want you to look at the ab squareds. There's 1ab squared plus 2ab squared. That makes 3ab squared. So those are done. Then we have just our b cubed. Okay, this is the line I'm going to add to my actual notes. Okay, that is it as simplified as it gets. So we're going to have our a cubed. We have plus 3a squared b plus 3ab squareds plus b cubed. Okay, let's do one more line and then we're going to revisit what we have written up there and maybe make some additions, okay? All right, I'm going to try to leave what I have here kind of sort of, but we got to do a b to the fourth. Okay, so I'm going to make a new line on my little scratch work. I know this is crazy, but I'm just trying to show you where everything comes from. Okay, so I'm going to get a different color here. I want you to remember that what we did back here is we had ab cubed, right? This was a plus b times a plus b times a plus b. Here I have ab to the fourth, a plus b, a plus b, a plus b. Okay, now remember how when we had, remember earlier when we had a plus b times a plus b, we had this guy. Well, I can include that. There's a couple ways to do this, but I can take that to replace here and then again for there. So really, it would end up being a squared plus 2ab plus b squared times the same thing. I know the algebra on this is nasty, but I'm just trying to show you where everything comes from so we can use a shortcut, okay? So you're not having to multiply everything out so extensively. Okay, so let's go through. We're going to FOIL everything. So take this a squared, multiply it by every term in this second factor, okay? So a squared times a squared is a to the fourth. And you may want to write kind of small. A squared times 2ab makes 2a cubed b. A squared times b squared makes plus 2a squared b squared. Nope, not 2. I'm losing my mind. Just a squared b squared. It's plus a squared b squared. So that was a squared times b squared. It's just a squared b squared. All right, now we're going to take the 2ab, this middle term, and we're going to distribute it to each of the terms in the other factor. So 2ab times a squared, that is 2a cubed b. Now we're going to multiply it by the middle term, 2ab times 2ab, that's 4a squared b squared. Take 2ab times the last term, 2ab times b squared is 2ab cubed. All right, now take b squared. We're going to multiply him by each of these in that trinomial. So b squared times a squared, that is a squared b squared. B squared times 2ab, that is 2ab cubed. B squared times b squared, b to the fourth. All right. Clean this up a little bit. I know it's ugly. So a to the fourth, that's the only one like it, so it's not going to combine with anything. Okay. Now, the next one, 2a cubed b. Look through and say, are there any more a cubed b's? Yes, there's one here, and then there's the 2a cubed b right there. I can look through. I don't see any others. So combine those two. 2a cubed b plus 2a cubed b makes 4a cubed b's. Done. All right, now look at a squared b squared. There's a squared b squared. I see another a squared b squared over here. Oh, and there's another one way over here. So a squared b squareds, we're going to add them together. We have 1a squared b squared plus 4a squared b squared plus 1a squared b squared. 1 plus 4 plus 1 is 6 a squared b squareds. Those are done. All right, go to your next one. ab cubed. ab cubed, okay? So we're going to add those together. 2ab cubed plus 2ab cubed makes 4ab cubed. And then my last term there, b to the fourth. That's the line I'm going to add to my notes, okay? So I'm going to go back to my notes page. I'm going to just remove this, and then I'll show you adding that in here, okay? So here we have a to the fourth. Then we have plus 4a cubed b plus 6a a squared b squared plus 4ab cubed plus b to the fourth. Sorry. The wrong thing. Okay, so we're kind of making a triangle out of this. Okay, that's going to come into play in just a few more minutes. Now, we can do another thing where we multiply this out, but I want to go ahead and backtrack and see if we can come up with a pattern, because we're gonna be here all day if we keep trying to do this. So we're gonna go ahead and come up with a pattern with this, and I want to add a few things in here. Okay. Number one, it is possible for us to write each of these lines where each term has both an a and a b in it. Okay. So I want to show you what that would look like. Okay. Right now, this is a to the first power. That's why we see it. And over here, this is b to the first power. Okay. But I could actually add a b term in here where that's to the 0 power. And I could add an a term over here to the 0 power. You just wouldn't see them. And you're like, why would you do that? Hold on. I have a reason. Just bear with me, okay? Also, there's a little leading coefficient here we don't see, which is just an invisible little 1. So add that in as well for fun, okay? All right, next line. Again, I could add in a little invisible coefficient there, 1. But again, each one of these I could actually write with an A and a B in it, even though you don't actually see it. So this is A to the second power, where I could also say B to the 0. Okay, I want you to look at this middle term. This is 2AB. This is A to the first and B to the first. Okay, this is really a coefficient of a 1, and I can write an A to the 0 power. So it is possible to write that. We're going to keep on with this pattern for just a second. Let's put an A and a B for every single term. This is A cubed. We're going to say B to the 0. Okay, I'm going to write in all my little 1 exponents wherever they exist. Okay, my 1 coefficient over here, this would be an A to the 0. Okay, so I want you to see what we've got going on here. We're going to show one more here. We're going to have, this is a 1, A to the 4th. I could write B to the 0. This is B to the 1st, B to the 2nd, B to the 3rd, but my A is the 1st. And then over here I can have A to the 0 with a 1 in front. Okay? So we're kind of building this thing, and I want you to look at this pattern. Okay? We may not bother predicting the 6th power. We'll just stick with predicting the 5th because that'll be easier. So if you look at this, what I want to do is come up with my pattern, and I want you to look at what's going on. Okay? We have our coefficients for every single little thing. Not only that, I want you to look the A to the 4th on this row. You see how that power was a 4? This starts off as A to the 4th, B to the 0. Now I want you to look at what's going on with just the A's. This is A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, A to the 0. You see that pattern? That's going descending. A to the 4th, 3rd, 2nd, 1st, 0. Now I want you to look at what's going on with the B's. B starts off as to the 0 power, but then it's to the 1st, to the 2nd, to the 3rd, to the 4th. The B's are going in ascending order, to the 0, to the 1st, to the 2nd, to the 3rd, to the 4th. Okay? We actually can predict it. And not only can we predict what the A and the B are, but I want you to look at these coefficients. At the beginning, we just have a 1. Okay? Then we have 1 and 1. But I want you to look here. At the beginning, there's always a 1. At the end, there's always a 1. In the middle, we can even predict what's going on in the middle because I want you to look here. What's 1 plus 1? 2. Look over here. What's 1 plus 2? 3. What's 1 plus 2? 3. Huh? What's 1 plus 3? Hey, that's 4. 3 plus 3? 6. 1 plus 3? 4. So you can even predict the next line. Look at this. We can predict it. We know that it's going to start with a 1. We know that the A will be to whatever power we're supposed to be predicting here. So this would be A to the 5th. We're starting off with B to the 0. And remember what we're going to do is we're going to add these coefficients. 1 plus 4 is a 5. This is going to be A to the 4th. My power for A goes down. Okay. This will be B to the 1st. It was 0. It's going up. All right, the next one. Let's add the 4 plus the 6. That's going to give us 10 for the coefficient. All right, we had A to the 4th. Now I want A to the 3rd. That's going to descend while your exponent on your B goes up. This was a B to the 1st. This will be B to the 2nd. Okay, in the next term, add your 6 and your 4 to get 10. We're going to have A to the, let's see, it goes down. It was 3rd. Next one is 2nd. B is going to go up. So B will go up to a 3rd. Get your coefficient, 4 plus 1, 5. We will have A to the 1st, and your B will go up to the 4th. And then our last term over here, remember that leading coefficient on that last term there will be, the coefficient on the last term is going to be a 1. This will be a to the 0, right? And then b to the 5th power since we're raising to the 5th. Oops, sorry. Zoom back out a little. So that's kind of what we've got going on there. So the next thing said, can you predict that next one? I'm going to skip that for now, but you could give that a shot, okay? I want to talk about these coefficients for a second because we have this thing called Pascal's triangle, and it's just an easy way to remember what those coefficients are. Okay, you can always draw this out and then just remember the variable rule and to go along with it. But if you have to the 0 power, you're just going to have a 1. To the 1st power, your coefficients are 1 and 1. To the 2nd power, remember, it's going to start with a 1, end with a 1, then add. 1 plus 1 is 2. Okay, start with 1, end with a 1. 1 plus 2 is 3. 2 plus 1 is 3. Start with a 1, end with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 3 is 4. Right? Start with a 1, end with 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Okay? You can have whatever power you want to and just build this triangle larger, and you can raise anything to any power that you want to. Okay? So we actually have this fancy thing called the binomial theorem. It looks like a nightmare. I don't really like using it in this format quite as well. I mostly just go based off of Pascal's triangle and the pattern, but this is just a really generic way to write that pattern. It's not my favorite, but it does work. I would write it down and you can try to follow it. The factorial, that exclamation mark, is a factorial, and it's when you multiply all of the values, like say that whatever number you have, pretend I did like 6 factorial. I would multiply 6 times 5 times 4 times 3 times 2 times 1. It's like all the numbers less than. You subtract 1, subtract 2, subtract 3. Anyways, factorial, there's a button on your calculator that does it. But I usually don't really worry too much about the theorem because I feel like it's kind of a mess. So what I'm going to do real quick is run through another example. We're going to expand what you see here. They said we're going to raise this binomial to the 6th power. Okay, and I'm just going to stick with this one example for time's sake, okay, because I really need to get going. So on this one, we're going to expand x plus 2 to the 6th power. And what I want you to do is think of that Pascal's triangle. Okay, I'm going to write an extra thing. This is my scratch paper. Pascal's triangle, if I have to the 0 power, you start off with a 1. This is the 1st power, 2nd power, 3rd power. Okay, so this is 1st power, 2nd power, 3rd power. You can keep going. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So again, I'm just adding the numbers that you're seeing above it. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5, 15. 6, 1. Okay, that's 3rd power, 4th power, 5th power, 6th power. So all of my coefficients are going to come from this row of Pascal's triangle. That's what I'm going to multiply my coefficients by, or multiply in my problem. So I'm going to keep that handy because I'm going to need it as I expand this out. Okay, so I just folded it so I can still see my coefficients in that row. And what we're going to do is go through that pattern. I'm going to have here, we're going to start off with 1. And then, so I'm going to just multiply it all out. We're going to say 1, then x to the 6th. So this number to the 6th times the last number to the 0. Okay? Then we're going to add our next thing, but we're going to start off with a 6. 6 times x. Instead of the 6th power, we're going to go down to be to the 5th. And then here, 2 to the, it was 0, now it's 1. Next term, start with a 15 times x to the, go down 1 exponent, 4th power. Then times 2 to the, it was first, this is the second. We go up. Now we're going to take a 20 in the front, times x to the third. Remember, that one's going to go down while the second one goes up in exponent. We're just following the same pattern. I'm going to use 15 next, times x to the second power. Remember, the exponent has to go down. While I have 2, the exponent's going to go up to the fourth. Okay, I'm running out of room because I'm writing with this marker that kind of bleeds. So I'm going to go down one line and add this one, 6 times my x was to the second. This x is going to be to the first. All right, 2 was to the fourth. Now it's going to be to the fifth. Then my last one's going to have a 1 times x to the 0, and then 2 to the sixth. Now I can take that away. All right, we're going to keep working through this. Simplify it down, okay? So this is 1 times x cubed times 2 to the 0. This is 1 times x, sorry, not cubed, to the sixth. 2 to the 0 is a 1. So I'm just going to simplify each term really quick. You can do some of this in your head, but you need to be really careful. X to the fifth, I'm just saying, is x to the fifth. 2 to the first is 2. All right, 15 times x to the fourth times 2 squared. So this is 15 times x to the fourth times 2 squared is 4. The next one, 20 times x cubed times 2 cubed, which is 8. Okay, next term, I know it's starting to get messy here. We have 15 times x squared times 2 to the fourth, which is going to be 16. Okay, add this next row. We've got 6 times x times 2 to the fifth, which is going to be 32. Plus 1 times x to the 0 is 1. I'm on this one. 1 times x to the 0 is 1. 2 to the sixth is going to be 64. All right, last little bit. We got to clean it up. 1 times x to the sixth times 1, x to the sixth. That one is done. Okay, then here I have 6 times 2 is 12. So this is 12 x to the fifth. It's done. 15 times 4 is going to be 60. We have x to the fourth. Okay. Done. Next one, 20 times 8. That's going to give us 160. This is x cubed. Done. All right, next one, 15 times 16 is going to give us 240 x squared. Done. 6 times 32 is going to give you 192x. It's done. And one last term, plus 64. That is your answer, all expanded out. It's a little less painful than actually doing it by multiplying them. All right, guys, that is it for this video. I gotta go. I will see y'all in the next one. Bye.